Hey everyone, this video is actually going to be broken up into three different parts. First, we're going to talk about writing quadratic functions and just like what it looks like. And then there'll be two other videos that talk about two separate ways to solve the problems for your homework today. So let's get started with writing quadratic equations. So first of all, recall the parabola's introduction. If you haven't watched that video, go back and watch that now. That was assigned yesterday. All you had to do was watch it. It'll give you some ideas of what we're talking about in this video. Recall from that video, there's two types of parabolas, some that open up and some that open down. You can see these pictures down here. So when we have these pictures, what we got going on is we have some that open down, which means the legs are just going downward, and it has a vertex at the top. And then we have some that open up with the vertex at the bottom. So for the sake of this class, we will primarily be using the ones that open down. And the reason for that is because projectile motion, things moving through the air, they tend to have that flight pattern. But for our practice problems today, we want to make sure we can calculate this under any circumstances. That way, once you go to your other math classes, you'll be rocking it, and it'll be easy, and it'll be a piece of cake, and you'll be like, thanks, Miss Burke, and I'll be like, you're welcome. Moving on. So there's different ways to write a quadratic formula. Now remember, quadratic formula is what makes these parabolas. Any quadratic formula that you have, it will create a parabola. So there's different ways to write your quadratic formulas. There's actually three of them that we'll talk about, but primarily one or two that we're going to use. So the first one is our standard form. This is what the form that most people use, hence standard form. You will have an ax squared plus bx plus c. So this a is just the coefficient of this variable that is to the second power. B is the coefficient to the just straight up x, and then c is just whatever straight up number you have left over. So the benefit of using this form is that c will always be your y-intercept. It's going to be where your graph crosses that y-axis. So just a heads up, that's part of the reason why that form is used. It's really helpful. Another form that's used is this vertex form, where y equals a times the quantity x minus h squared plus k. Whew, that is a mouthful. But the benefit of using this is that this h and this k are actually the coordinates of the vertex. So if you wrote it like this and you just looked at the equation, you would know exactly where the vertex is, or in our case, your maximum height. The final way to write the quadratic formula is the factored form. So this is the factored form here. F of x, just anytime you guys get to higher level math, that's just what the y is. It's just a function. Don't worry about it if you're not used to seeing it. A is the amplitude of your parabola. We'll talk about that next week. But the biggest thing here is that these r's are your x-intercepts. So the cool thing for this, when we get to our catapults, is those x-intercepts are where it hits the ground. So we'll calculate that, don't worry. But the cool thing about the factored form is it has our x-intercepts. So all three different versions of the ways to write the quadratic formula, all of them have their advantages, but standard form is typically the easiest way to plug it into your calculator, and it's the one that we will primarily be using. We will use the factored form to find our amplitude, but standard form is what we're going to actually use to graph our trajectory. So yay. So why do we want to use standard form? What's the benefit of having this 3x squared plus 4x plus 5 instead of having all those fancy parentheses? Well, first of all, it's a lot easier to plug in a calculator. If you have a graphing calculator, if you try and type it out, it's a nice, easy way to plug it in without having to worry about those parentheses. Then you forget one, then a mistake happens. You're fine, you're fine. So there is another advantage. The standard form can actually tell us a lot. If you look at that number in front, that purple 3, it tells you how skinny or fat the graph is. What I mean by that is if that number is really small, you're going to have a fat or wider graph. If that number is really big, it's going to be a really narrow or skinny graph. If you look at the graph to the right, we have that black parabola. Sorry, I had to draw it myself, so it looks like garbage, but deal with it. So I have that regular graph. Now, if we make that front number smaller, it's going to make our graph wider. That green graph that's on there now, if the front number is smaller, boom, it gets wider. If the front number is bigger, it actually gets narrower, which is weird, but that's what happens. And that's why putting it in this form can be really helpful. Because just by looking at that number out front, we kind of can visualize what that parabola should look like. The larger the number out front, the more narrow that is. So, quick question, which of these equations would make for a skinnier or a more narrow parabola? Would it be A or would it be B? Pause the video now if you want a little extra time to solve this for yourself. If you're ready to go, A is the correct answer. The larger that front number is, that 8 is larger than 1.5. So if 8 is bigger, it must be skinnier or narrower. What's another reason to use the standard form? Well, that front number can also tell us if the graph opens up or down. So you can see that purple 3 up front. It's still useful not just for how wide that parabola is, but whether it's going to be opening up like it can collect water, or opening down like a hill, if you will. So a positive front number means it opens upwards. A negative front number means it opens downwards. So here's some examples. The green shows you it opening up with those legs where if you poured water in it, it would collect it kind of like a bowl. That means the number out front is positive. Now, if that number is negative, it's going to look more like a hill where those legs are pointing down. And that's mainly what we'll be using when we do our formulas next week for our catapults. All of our formulas should have a negative front number unless you are defying physics, which I would be impressive. So which of these equations would make a parabola that opens down? Would it be A or B? Pause the video if you need more time. If you don't, the correct answer is B. Yeah, negative 1.5, because if that front number is negative, it must open down. Yay for standard form. Gosh, that teaches us a lot. So let's try it out. What would this graph look like if we had y is equal to negative 864x squared plus 12x minus 37? What do you think it would look like? Would it be a fat parabola opening upwards? Would it be a skinny parabola opening upwards? Would it be a fat parabola opening downwards? Or would it be a skinny parabola opening downwards? Pause the video if you need a chance to think about this. If you don't need any more time, and you said, what's that? A skinny parabola opening downwards? You're right. That front number is negative. We can see it's negative 864. The negative tells us it opens downward. And that big number, 864, tells us that this parabola must be pretty narrow. Yeah, look at us visualizing a graph just by looking at the standard form. My goodness, look at these skills. So D is the correct answer. Yeah, I already explained that. All right, so how to convert from factored form to a standard form. Now, all those different forms that we learned about, right? We had factored form, we had standard form, we had vertex form. Fun fact, these will create the exact same equation if you just switch some things around. We just simply put them in their basic form so that it makes it easier to visualize the graph right away. Again, standard form is what we primarily use. The factored form is sweet because it has x-intercepts. The standard form is sweet because it's easy to put in calculator and it's standard. So how can we go from one to the other? What we're going to do in the next 2 videos is show you 2 different ways to go from the factored form to the standard form. So you can watch those videos on your own. One is the FOIL method and one is the box method. And that's what those videos will be about. So if you have any questions, go ahead and ask me at any time. But other than that, that's it for this video. Thank you for watching.